This podcast is supported by Siemens, your partner for industrial-grade AI.
Hey, it's me, Robert. Before we start with Sepp Hochreiter, please all remember our AI event in January. We are organizing it together with the Hannover Messe. More about it in the show notes. Thanks a lot, and now enjoy listening. Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber, and in Munich, not in Munich, in Italy is...
Peter Seeberg. Hello, Robert, how are you doing?
I'm fine. And in Linz is...
Here is Sepp Hochreiter.
Welcome, Sepp, to the podcast.
Yes.
I met Johannes Brandstetter last night, and he was very enthusiastic about your xLSTM approach. You were in Berlin and presented the first results. Give us, please, an update. What are you doing? Why is it needed from your point of view? What are the advantages?
Yes, I'm happy to do that, but I have to be careful not to reveal too much because it's not published. We don't have the IP rights right now. And that's a technology I want to keep in Europe. I want to keep in Germany and Austria. Let's see whether we can do that.
So give us an update, a bit.
As you know, everybody is talking about GPT, ChatGPT, stuff like that. And this is a transformer technology. Before transformers, there was LSTM technology, long short-term memory, which was invented by myself. And published is together with Jürgen Schmidhuber, and then all big companies in IT branch picked it up. It was in Alexa, in the Apple iPhone, and in Android and whatever. And then things changed. There was one paper, is attention is all you need, because attention was made with LSTMs inside. But then they said, hey, we can do attention only, and we don't need attention anymore. And then now all technologies working on text, these large language models, use the transformer technology. And the transformer technology has two big advantages over the LSTM technology. First, it's fast in training. It can do everything in parallel. It can in parallel process all words because the words are known in training. And the second big advantage, it's memorizing the words as they are. It's really memorizing the tokens, the words as they come. LSTM is autoregressive insofar it cannot do everything in parallel. LSTM has a big advantage. It can do abstraction. It can extract the most important characteristics, features, ideas of words, but it has a hard time to precisely store every word. And this transformer technology is the leading technology right now in ChatGPT. But then I saw we can do better.
How?
Yeah, I will not say how exactly, but we can improve the LSTM by something like exponential gating. And we can also enhance LSTM by storing more. It's like a vectorized LSTM. These two features together led to xLSTM. And that's an analogy of the human verbal short-term memory. Humans have two kinds of memories if they listen to words or are reading words. So one is phonological. You remember the sound. And the other one is semantic. You remember the meaning of words. And there are many, many experiences and experiments in cognitive science where only nonsense words without semantics were said, and then words with semantic meaning were used. And it turned out you really separate memory for the phonological, for the sound, and for the meaning. And if them is missing, you perform much worse. And now this is an idea of xLSTM. We need both. I think we need both. We need a memory which really records the words. I have to remember, was it European Union or was it European Commission? In a semantic way, perhaps you would not remember, but also you need semantics. Are we in a friendly environment? Is this a friendly talk? Is it about sports? There are so many words about sports. Is it about holidays? You want to not store all words one after one, but also some global context. And here LSTM is good. LSTM is perfect in this, but it's not sufficient to perform as well as transformer alone. But if you now combine both with the xLSTM, we did it and we outperform the transformer technology, so GPTs. We are much better than the GPTs on all data sets we tested. Okay, given these data sets are small data sets, but we are...
You mentioned GPT 2.5, right?
No, it's not the GPT-2. GPT-2 is the baseline we always use and extend. And we are much better here for small data sets. And it's now a big problem because all my PhD students are so excited. They want to publish, I want to show what they have. But right now, I want to keep this technology in Europe because the transformer technology is a patent held by Google. LSTM is not patented. xLSTM is not patented until now. That would be a technology which is free, which is in Europe, and where all the know-how is also in Europe. And we are so much better, but I cannot keep back all the students because I say, hey, let's try out whether we are really better than OpenAI and Meta with all their stuff. And believe me, the transformer is used in an autoregressive way, but it's not autoregressive. It's something you should not do. Please use an autoregressive method for an autoregressive setting. The only advantage of the transformer was it was so good in training in parallel, and therefore they used a non-autoregressive method for doing autoregressive stuff. And now they have problems. The transformer is quadratic in the number of words it's memorizing. It's quadratic in the number of contexts. xLSTM is linear in the number of contexts, meaning if you apply it, we are not only much better, we are also much faster. We need less memory, we need less compute. Not for training. For training, we still have the heavy load as the transformers. But if we use it in inference, if you apply it, transformer is quadratic, has quadratic complexity runtime, and we have linear runtime. We are much faster and we are better. And that's fantastic. That's unbelievable because I never would have dreamed about such a success because normally you're always very close to the state of the art. You never reach it, then you have to tweak and tweak and tweak. But here, for the first time, we tried it out. We were better than GPT-2, the base method of also GPT.
There was also criticism after your presentation. The symbolic group in particular, some spoke of skepticism in the audience. How do you explain that?
Yes, because they say the transformer or these large language models, they are hallucinating, they don't tell the truth. That's not what I'm saying. I don't tackle these problems. There would be other techniques. I only say the base technique. We have a better base technique. But this base technique does not improve on other problems, like all these autoregressive methods randomly generates the next word. So selects the next word according to some probabilities. We do the same. Our technology is better than this technology, but it has the same problems than all this technology which predicts the next word. They cannot tell the truth because they're only guessing the next word. If there's no information in the input, if there was no information in the training, it's not there. And here's the symbolic guys kick in. It's a criticism on the whole technique learning. If you answered something which you never have learned and you are forced to answer something, then you sometimes answer things which are not correct. That's a principal problem. But that's not my focus. My focus is what's out there by OpenAI. It's some technology where we have much better technology here in Europe, here in Austria.
Peter?
Sepp, hello.
Hi.
It's a couple of months ago we saw each other. How are you doing?
I'm almost exploding because I have such a good method and yeah.
You were already almost exploding when we saw you a couple of months ago. First, from my side, congratulations with receiving the German AI prize by from Axel Springer. And
thank you.
I understand that you received, or you will receive soon, 35,000 euros. Now, I think there was a bank director a couple of years ago who said that's peanuts, because I understand, but nevertheless, as I say, congratulations. But I believe you're looking for a lot more. You're looking for 300 million euros. What for?
Yes, that's true. My goal is, and I told all my students, we want to kick OpenAI from the market. We want to kick this GPT bullshit from the market because it's not the best method. We have a better method. But if you listen to Ilya Sutskever, as I trained the GPT 3.5, they used 24,000 GPUs for a couple of months. And this costs about 100 million euros. And this is the last run. We also have to do the explorative runs before that. We have to check out what is the best architecture. We have also to explore the scaling laws. We would not go for the largest data set. We first would do smaller data set and see if we use larger models. Does it improve? If you use even more data, larger models, does it improve? And then we can extrapolate and say, I think now we are there, we can do the big model. But all these runs and all trying out different architectures, parameters, also costs compute time. And therefore, 100 million for OpenAI for doing one model, and we have to explore it because they already had a model transformer which was well explored by the whole community. And here we also need a little bit more to find the best architecture and then scale it up, and then we are fine.
But I heard some rumors that maybe there's a solution, right?
Now, there's the first guys telling us, saying they will support us. We have now one project where money comes in, especially for compute. And I'm super happy because we talked to many venture capital guys and said, yeah, do you have a business plan? How do you want to make money? I don't want to make money. I want to keep this technology in Europe. There are many other companies who can make money. But otherwise, the guys from Saudi Arabia, from China said, hey, they will finance this. But then it's gone, and the technology is somewhere else. Also, if I go to Meta or if I go to Google, they will probably do that. Now I want to keep it. I have it on a silver tablet. I give it to the Europeans. If they take it, then we have the technology here. If not, then the technology is somewhere else. And still can fail. Also, this is things that at a certain number of data, something it breaks down. Who knows? But it doesn't look like this. Momentan, I'm optimistic.
Now that's a structural difference from. So we're in year 25 of LSTM for those users that listeners that are not aware. You gave an introduction to LSTM. It took 10 years and then it took off. And people have been saying, and you were saying yourself, so there was no IP on LSTM. And let's say in general, if you want to talk in more detail, feel free to do that. But big tech, let's put it that way, has been the big users and, those that have made money, so to say, with your technology. Now, that's going to be different. Is that what you're saying? Your plan is at least that now, are you going to put certain IP rights into the new updated xLSTM as well?
Yes, I want to keep it. Perhaps it's the IT rights. Perhaps it's not the right way to do it, or keep the know-how, how to apply it, how to train it, how to use it. I'm not sure what is the best thing. Also, with on university laws, I don't know whether this works with IP rights or the university want to have them. Because also everything I have to go very fast, because if I wait half a year until everything is clear, others will also have found the method or will see it. I think right now there are a couple of alternatives to transformers. Something is going on. And after they know what I'm doing, there could be the first research groups which also invest in this direction.
I have one more question. You mentioned transformers. Do you think that is the era of transformer ending?
I don't know. Where transformers are very good. We also did this experiments is if we have rare words, if we have really to store the words, the transformers are better because what we're doing not the original transformer in our xLSTM, but some recurrent network. And here you always have the stored information superimposed. It's so clearly stored like transformers. If you want to store every item exactly, you need this quadratic kind of thing. And if there's something you have to precisely remember the word, was it this word or this word, and that transformer could still be better. But I think in almost everything, 99%, we can beat transformers. I would not say it's completely over, as also LSTM was not completely over because LSTMs were used
in a lot of industrial applications. Yeah.
In many things. And I think there are distinct niches where transformers are used, but I think the xLSTM is so powerful, it can be used in many application areas, especially in engineering applications.
Can you give us an example?
Yeah, perhaps I can do, but I shouldn't do. Some of my students applied it to like a hydrology thing and says, hey, Sepp, with our xLSTM, we're much better than everything else. And I said, yeah, yes, I know it will be everywhere better than all these control systems. But right now, I want to kick OpenAI from the market. We have to keep our mouth. We have to be quiet. Because if this fails, then we can apply it to so many other areas because I know it's much better in many areas.
So is it a large language model from your definition? I think yes.
Until now, it's not so large because the large thing, we don't have the computer to do the large. But we can make it large.
Okay. But you said you can use it in engineering topics, right?
Here it would be like process control, logistics. Here it works better than previous methods. But this comes later. To improve all this engineering, technical things, I know I can do it. And that's a backup plan. The first plan is kick OpenAI from the market.
When is the paper on xLSTM coming?
I don't know, because first we are looking for funding. We are checking, should we keep the IP rights? Is this even possible in Europe because of software and so on? Everything is not super clear how to do it. Also, all my team should participate here, should be part of it. I want to do everything correct with the university because this university invention, also with my guys who wrote CUDA coins, did so hard work and so excited. They're so excited you wouldn't believe. They see everybody is talking about something which we beat so easily. And you cannot keep them back. Also, they should have their reward, should be rewarded for what they're doing. And I'm trying to set everything up and to be fair to everybody.
What are the next tasks in your group now? You mentioned the IP stuff.
Yes, that's what we do on the side to sort this out. But my guys trying to write fast CUDA coils to make it fast, because we're still not as fast as Transformer. We are faster because of the quadratic thing, but in training, we are a little bit slower. If the sequence length, the number of words is large, then we are faster because of the quadratic law. But for the standard stuff, we are a little bit slower. And here we need these fast CUDA coils, these hardware implementations. And we're working on this. They exist for transformers, but they don't exist for the new method. And we are developing this because if you're super fast or as fast as a transformer, then we have better chances to go for the big data.
Peter, last question.
Yeah, 2 questions, if I may.
Yeah.
I can feel your excitement through the microphone, and I'm sure our listeners can as well. First thing is, if Google, I believe, correctly translated from your interview with Die Welt, you say, we will kick dump GPT away. I may assume that with dump, you mean that today GPT and all the other large language models are, let's say, non-understanding, non-sapient. Is that correct? And that means implicitly that, and I think you did kind of an introduction into that xLSTM is going to be more like understanding its environment, so to say?
It should have both. It should have like the attention mechanism, like the transformers, memorizing everything precisely, but also extract semantics, extract meanings, what we are talking about on a higher level. Where we lose the precise words we have said, but we know the meanings, the feelings, the emotions, or whatever. And both is important, I think. And yes, that's a new thing.
Okay, so I shared your interview a couple of days ago on LinkedIn, and there was a list of replies. I'm going to share only one because the other ones you have kind of answered. It's from Daniel Tremer, quote unquote. Good luck. Hope there will be competition in the field, but I'm skeptical. Daniel says there are a lot of open source models doing great or better than GPT-4 in specific fields. So it's not about the model, but the engineering behind OpenAI, which you, Sepp, has to kick away, quote unquote. And that's not what he will be capable to do easily, quote unquote. What is your comment to Daniel?
Yeah, different levels. First of all, there are of course many models here, but they use basic technologies. They download something like Llama from a meter and do the fine tuning, the human alignment. That's what they're doing basically. And I know also from OpenAI, they invested a lot of time and money to doing the fine tuning. We are not focusing on this. That's true. We only want to show with the raw data, would be a model which is not usable for applications right now, we are better. But then there could come in the companies who are doing the fine-tuning, the human alignment. But that's not our reason. We want to, the basic technology we want to change and not the things afterwards like the human fine-tuning. Here we wait what turns out to be best and then we will use it as it is, but it's not our focus.
Great, thanks.
Sepp, it was a pleasure.
Sure.
Thank you very much for a bit insights into xLSTM.
Yes, I hope I did not reveal too much that the big companies are already starting to implement it, but no, it was also a pleasure from...
It was our pressure, yeah. Thank you very much, Sepp. It was a pleasure.
Thank you very much. I'm wishing you and your team at Johannes Kepler University in Linz that you're going to shake up the large language model really well. Thank you very much for your time.
We are trying. Thank you.
Thank you very much.